Hey there, students. So today we're going to talk about welding fixtures again, but this time we're going to look at them from an industry perspective. So this is from a presentation that was put together by Ben Otten, who works out at Woodstone. So that's out by the airport, and they make pizza ovens like the one down here in the corner of the slide. And Ben is the person who designs the fixtures, especially for welding and for sheet metal bending, as well as the end-of-arm tooling for the robots at Woodstone. And so he has come in different years to talk to the class. This year that doesn't make much sense because of the way this is working. Also, he has to take time off, take vacation time to come talk to us. So I'm just going to talk through his slides today, but I think you'll find them to be really useful as we go through. So we're going to start out by understanding some welding symbols and welding terminology. This is all really relevant to you because your next project is a welding fixture, and so all of these things, both the welding symbols and then the practices and best ideas that Ben has presented here, are going to be really important for your project. So let's get into it. Okay, so when you have a welding callout, the welding callout consists primarily of this leader line. So the leader line is this piece right here, the arrow, and then the leader line, and then sometimes it has a tail and sometimes it doesn't. Okay. So, things that are really important with this. First of all, anything that goes below the line applies to the side of the weld that the arrow is pointing towards. Anything that is above the line, in this area right here, applies to the side opposite where the arrow is pointing. Now, why would they do that? Well, a lot of times you can point to the outside of something, but you actually want it welded on the inside, and that's hidden in the view, but it's still the best view for identifying things. All right, so other things that are in here that are really important. So when we'll look in a minute and see what kinds of items could be listed on the arrow side or on the other side, but it's a lot of information about the type of weld to do. Other things that are important are the size of the weld. The size of the weld is measured based on the leg length of the weld. And so if we look at that, this weld is called out as a 3/32 weld. It is a fillet weld. This is below the line, so it's on the side toward the sorry, lots of sirens outside. It's on the side that the arrow is pointing to, and then we have these other numbers over here. We can see that that is the length and the pitch. The length is how long is each weld, and the pitch is what is the distance from center to center of the different weld beads that are put on there. Okay, so the leg length is the back edge of the weld, not the hypotenuse, but the back edges of the weld. And if there is only one leg length listed, then the assumption is that the weld legs are equal. If there are two numbers here, then they could be different leg lengths. Okay, so that is the leg length, or I'm sorry, the size of the weld, which is a measure of the leg length. And then the other side is the length of the weld. So here, this is a 2-4, so that's 2-inch length of weld, and then 4 inches center to center. So there's a 2-inch long weld, and then it is 4 inches from the center to center or from the edge to edge, either way, till you get to the next weld. Now, why do you weld in little sections like this? You often do that because welding imparts so much heat to something that it will cause bad warping. And one way to reduce the warping is just to put in less heat by using small amounts of weld rather than an entire weld. Okay, what else can be in here A lot of information, but the other thing that we're going to look at mostly is this finishing designator up here. And so the finishing designator would have things like ground. If you are going to grind the weld when you finish, or do some smoothing operation on it, that would be listed up here. Okay, now in this section of what can be put on, the arrow side or the other side, let's look at that for a minute. So it's really an extensive list. If it's a triangle, it's a fillet weld, and you can see that the way that you look at this is these are all, well, I'm sorry, from right here to right here are the symbols for fillet welds, plug welds, slot welds, spot welds, stud welds, seam welds. And then down here is the groove type weld, so square V, bevel U, J, flare V, flare bevel. Okay, you may not know a lot about all of these welds, but anyway, the fillet weld is the most common weld to be used, and you can see it if it has the symbol below, it's on the side that the arrow is pointing to. If it is above the line, it's the side opposite the one that the fillet's pointing to, and if it's above and below, then it's on both sides. One other symbol that you will sometimes see that we didn't really, talk about on the last one is this is really important, is weld all around. So that will be, okay, if we're going to weld everywhere, I want you to weld all the way around. So you only have to point at one place, but all the way around, everything that's similar, going to weld that way. So it's sort of like the propagating that CATIA does when you select a chamfer or a fillet, and it will propagate that all the way around the part. Okay, there's a tremendous amount of information here for other types of welds, and it's really important to understand if you are a welding engineer or if you need to do welding. And so it'd be good to learn those things if you're going to be doing that. But we're going to leave it at that. We will finish this portion by talking about what does the arrow side or the other side mean. Well, if you have a butt joint like this and you say that we want to do a V groove weld, that means that you're going to take this and you're going to either grind or machine a V groove into it and then weld inside that V groove so that you get really good penetration between the two materials. The arrow side would be here on top of the part, and then the non-arrow side, the opposite side, would be down here, and you can see that that is, that's a hidden view. And so you would point to this one and then say do it on the opposite side. The same thing for corner joint, T-joint, and lap joint. Lap joint is pretty confusing to me about what the near side and the far side means, but anyway, you can use this as a reference if you need to. So let's look at an example. This is a part that is made by Woodstone, and you can see that it is pointing at two locations. And so if we were going to look at this, it's telling us to weld along this line, whoops, and then down this edge right there. There we go, down that edge. And it just erased it. Okay, now other things that it says is that our weld size is going to be, the leg length is going to be 30/32 of an inch. We're going to be welding on the near side, or the side that the arrows are pointing to, so we're going to be welding on the outside of this box, not on the inside. And we want the finish to be convex and a ground finish. That means that we're going to end up with a nice smooth corner on here. They want it to be, use a grinder after you finish to make sure that it is smooth. And then we see behind the tail here, GMAW, so that is gas metal arc welding, so that's MIG welding. And then typical. So typical means anywhere that there is a line like this, or like these two that it's pointing to, we're going to want to weld in those places. So we're not only going to weld here, but we're going to weld, I pressed the wrong button and it caused that to come on. So we're going to weld right there, We're going to weld here and also along that edge, along this edge, and then this bevel right there. Okay, so we're going to weld in 4 places on this one. We also look at the notes and it says all welds must be solid, free of surface holes, and resurface all welds to blend with the finish. So what they're trying to do here is this is visible. It is the control box, and so they want these to look nice, and then they don't want them to be sharp at all, and they need to not have any surface holes because it is for cooking, and so it may be steam cleaned, and this needs to be a sealed box to keep any of that out of the electronics. All right, so this little 5 over here, I'm not 100% sure what that 5 is, but it goes with this drawing, not this drawing. And so it doesn't go with this weld call out, I believe. All right, that is an example. So in the next lecture or the next video, what we're going to do is we're going to look at some fixtures that were made by Mr. Otten. So video B will look at a fixture that he made and a part, and we'll think about how those two work together. In video C and D, we'll look at specific types of components that he uses in his fixtures and how those are applied. Thanks for watching.